Hello and welcome to this video in the measurement series. This one is on the volume of pyramids and cones. So we're going to start with pyramids. Okay, so pyramids are those wonderful shapes that you find over in Egypt that the ancient Egyptians are credited with building. Now, all the different types of pyramids that we're going to look at today, they work in very, very similar fashions when it comes to the formula itself. Now, something that we know about pyramids, okay, is pyramids can fit into a regular prism. Okay, so a regular prism like a cube or rectangular prism, that sort of thing, a pyramid can actually fit into one of those. Okay, but it doesn't take up the whole size of that prism. It doesn't take up the whole size of the prism. It actually only takes up a third of the prism. Only takes up a third of this space. So remembering that the volume is the amount of space that it takes up, that the object takes up. So instead of being V equals AH, which is for the regular prism or the right prism, where we have a standard cross section, we are going to have a third of that for the pyramid. Okay, so area of this, the A obviously being for the area of that face or the area of the base of the pyramid in this case, and H is that perpendicular height of the pyramid. Alright, so A is the area of the base of the pyramid, and H is our perpendicular height of the pyramid to the apex or to the point at the top. Okay, so those are those bits that we need to understand. Now in my table here I have some examples. I have the square pyramid. You can see there we have the square base, so we have our base at the bottom. They are both the same size. We have our perpendicular height. Rectangular pyramids works pretty much the same way, except for now we have B and L, or B and H, however you want to put it in your formula. We have the triangular pyramid, which works exactly the same way. So we have a third of the half BH there times the big H for the whole thing. And we've included in the table the formula for a cone, which actually works the exact same way as a pyramid because they are very, very similar shapes. The only difference being with the cone, we have that circular shape at the bottom instead of that linear shape at the bottom. So now that we know that the pyramid fits inside of a regular prism, but only taking up that third of the space, we can go on now and have a look at a couple of problems. Let's look at our first problem here in the on the screen. We have a square pyramid. It has a base height of 6 meters, or a pyramid height of 6 meters rather, and a base height of 5 meters. We have a square base on our pyramid. We have this square base on the pyramid. So now we can use that very, very top formula, which is this one here for question 1. Okay, so we're going to start with just having V equals 1/3, because as we said before, this pyramid is only taking up a third of the space of a regular prism. AH, which is our volume of a prism. So we have times S squared for the side, squared for the area, times the H, so the perpendicular H. There. Now, let's substitute in, because we've separated that all out. 5 squared times 6 meters high. Once we calculate that out, we're going to get 50 meters cubed. Okay, so the volume of this particular pyramid is 50 meters cubed. So don't forget to use your cubic units at the end in the final bit. Now, occasionally you may be expected in a word problem to answer in words. So to do that, use your little therefore symbol. So that's the 3 dots that form a triangular shape. And then just write a sentence explaining what you've just calculated. So I should have the word "the" in there. Now you can write it just like that, or you can even write the words 50 cubic meters if you'd like. Now let's move on to example 2. Example 2 is the cone. Example 2 is the cone. And we've got our distances in the cone itself in the diagram. So here's our radius here. There's our radius. And there's our perpendicular height. Remembering that perpendicular is that right-angled height, so that height at right angles to the base. Now there's something slightly different about this particular question. This one's asking us to answer correct to 3 significant figures. So we'll get to that little bit at the end, talking about significant figures, because these are different to normal rounding in terms of decimals and things like that. So again, let's start with our basic formula of V equals 1/3 AH. Okay, so it's going to be 1/3 times pi r squared, because that pi r squared is the circular base of our cone times our perpendicular height. So we have 1/3 times pi times our radius, which is 5, squared times our height, which is 12. And again, just calculate through, and we're going to get 314.1592654, and on and on and on. But as we said before, we're looking for significant figures. Now, significant figures are a little bit tricky at times. There are lots and lots of rules around significant figures, but all we really need to understand for our purposes right now is that significant figures are any non-zero number, basically. Okay, so any non-zero number, so we want the first 3 non-zero numbers. Now, sometimes the 0 can be significant, particularly if it's in between other numbers. But in our case, for our answer, we don't actually have any zeros to worry about. So we just round off to the first 3 figures, which is 314 to our decimal point. So we cut off our first 3. We look at this number here. We ask our 2 questions, because this is still in terms of the base 10 number. So we're still using 5 as our halfway point. Alright, so is it 5 or above? Is it 4 or below? Now, remembering that these 2 numbers are inclusive, so 5 is included in the above, 4 is included in below. That's just a 1. 1, that's 4 or below, it fits into that category, so it's just going to be 314. So remembering to use our approximately equal to symbol, our squiggly equals lines, because we are rounding off. Now, in the previous question, we didn't need to do that. We didn't have anything to round, so we could use the equals. It was an exact answer. So this one is going to be an approximate answer because we are rounding. And then we have our cubic units. And again, if we'd like to do a written answer, like a worded answer, use our therefore symbol, our 3 little dots, and just write out a sentence. In this case, the volume of the cone is 314 cubic meters. And that's how you do it, folks. They're not too difficult on this one. Fairly straightforward once you start getting the hang of those processes, and it's just how you apply them that make things different. Hopefully this has helped you with these types of problems, and we'll catch you in the next video.